So first of all, you should know the fundamental clearly. Then we can build the knowledge further. One example here. So here I have the DC machine. It's running with a speed of 1000 RPM. It's a typical example. And we have the supply voltage 200 volt. And of course, in the machine at the load side, we have 196 volt. Now I want to reduce the speed of this DC machine to 500 RPM. So what can I do here now? So first of all, if I want to reduce the speed of this machine, I have to reduce the EMF, electromagnetic force. I'm not sure you have studied about this course, EMFT, electromagnetic field theory, Faraday's law, and so on. So you know how the machines are working, how generators are working, because we have the winding inside. That is kind of inductor. So winding means like, you know, this is a copper. It's not visible. Okay, fine. So copper wire, right? The copper cable, we are just winding on some core and we are giving the power supply. So when you give the power supply, then there will be the electromagnetic field will be created. And if you also have the surrounding side, that is why we have an armature, either in the DC motor or AC motor. You have the center core and then you have the surrounding windings. So you have the opposite polarity. So the magnetic force will oppose each other, then the rotor will start to rotate. Okay, that is the machine principle that I'm not going to talk here now. So how this rotor is rotating in the machine, that is based on this electromagnetic force. So if you reduce this electromagnetic force, EMF, then you automatically reduce the rotation of this rotor. So that is what I am saying here. You are going to reduce the EMF. So to reduce the EMF, you have to also reduce the, how can you reduce the EMF? You have to reduce the supply voltage. So traditional method, how we can reduce was, we can add some kind of external power supply, sorry, external resistor. So between the source and the load, I am adding some external resistor. So the power is dissipating here. So I am making this resistor which can dissipate half of this supply voltage. So I am dissipating 98 volt as a heat. It's waste actually. I am wasting the power as a heat. And here we have the load. Then I am having only 98 volt, which is coming here. And then according, of course, the current is coming and it will create the EMF accordingly. And then the DC machine will automatically slow down to 500 RPM. But you should know, this is not really an efficient method to add external resistor to control the speed of the machine. So to reduce the speed of the machine, we need to reduce the EMF. Okay, this is the formula, pi Pn divided by 60 multiplied by Z by A. And here N is the speed. Okay, so E is equal to pi Pn divided by 60. So just remember this formula here now. So E is directly proportional to the speed. E is what? That is the EMF, energy, and N is the speed. And if I reduce the E as half, then I can reduce the speed of this DC machine to half. Okay, this is the principle. So I can use any method, an efficient method to reduce this EMF. Let us say right now the EMF or E across this machine M is 196 volt directly from this power supply. So we need to add one resistor which can dissipate 50% of the supply voltage, circa 98 volt. Then the machine will automatically get only 98 volt. Then the speed will be reduced. But because of the increased loss in this middle part, the efficiency of the machine will also be reduced. So you should know the efficiency, because when we talk about the power electronics, this is a very important term. You should remember efficiency. Okay, so what can we do then? So instead of adding OR, we can use a PE device. PE device means what? That is a semiconductor switch. So semiconductor switch, that can be a power diode or a power thyristor or SCR, or there are so many number of devices are available. And these devices are basically manufactured by using semiconductors. Conductor, semiconductor isolators. I think you have studied in your other course about this detail. If we talk about these semiconductor conductor isolators, then it will take another few minutes. So I will just jump to directly into continue our topic. Okay, so on state drop is very less. As I said, like we can control the duty cycle on off like that. So by controlling the duty cycle of this device, we can control the speed of the machine, because on state drop is very less and the overall loss is really less. Even though after you make the average, the loss is much lesser. The efficiency of the machine will never get affected, or it will not get affected too much when compared to using this previous method. So using this power electronic device and controlling the speed of the machine is the wise solution than using the resistor. So that is the power of power electronics. I would like to give one more small example. That is a fan regulator. Maybe in Norway, mostly people are not using fan, the electric fan. It will just give a air to you. But in tropical countries, almost all homes, they have the fan. Because it's too hot, they want to have the fan. Not everyone can afford to buy the air conditioner. Fan is much cheaper. So in the fan, you can control the speed of the fan. Sometimes you want high speed of the fan. Sometimes in the later getting more and more in the evening, it will get bit more colder. So you want to reduce the fan speed. So how can we reduce the speed? So we are using the regulator. So we are using, in the olden days, the regulator looks like this. It's so bulky, really, it looks like a big box. So by controlling this knob, you can control the speed. Even in restaurants in Norway, they are using this exhaust fan. So when the people cook the food, it will suck the air and then it will just dump the air outside of the restaurant, right? So there also we have the speed control. We have the same fan regulator, the same principle. So here we are using variable resistor inside. So when I put the resistor here in number 1, so maybe less voltage drop, and then I put here, there will be more voltage drop. So the fan speed will be more reduced. So I can just adjust the knob wherever I want. So what is happening inside here? I'm just changing the variable resistor value, and I increase the loss or I reduce the energy loss. As I said, this is not really an efficient method of doing this. Even 20 years ago, even 10 years ago, I think people were using these traditional variable resistor based regulators. But nowadays, we are using this kind of power electronics based fan regulator. You see how nice the switch, the regulator is. The same function, but the size is much smaller, maybe 10 times smaller than this regulator. So that is the beauty of power electronics. So power electronics, the size is smaller, the cost is low, the efficiency is high. You can achieve the same speed control of the fan by using this fan regulator, but it's also much smaller space it's occupying when you install. It's easy for the installators. Maybe some of you already have working experience as an electrician, right? So how easy to use these kind of fan regulators. So advantages of using this P device in practical applications. For example, in this case, to reduce the speed of AC machine, attach a conventional resistor and increase the losses in the system. Anyway, it will reduce the EMF across the machine. Resistors makes the system big in size, and it requires cooling system. Of course, if I use this kind of resistors, the power is dissipating in terms of heat. Then I need a heat dissipator. Then I need a heat sink. What the heat sink is doing, heat sink is absorbing the heat from the resistor and just dissipating outside. So if you don't have the heat sink, what will happen? it will get more and more heat inside this box, then it will just burn. You will get the smoke. Then you have to change. So that is one problem. So, but in power electronic devices, you do not have such a big issue of using heat sinks. And the size is much smaller. So P devices can replace these resistors, reducing losses, reducing the size, no heat sink requirement. In some applications, of course, you still need heat sink, and it's more controllable and it has high efficiency. Okay, this is another example. So far, what we have learned until now, in order to save energy, there must be a separate power processing unit in between the source and load. In between the source and load, we have the power processing unit, and which gives the controllable input to the load. So we can give the controllable input to the load. This is the input to the load. For example, the electrical machine, DC machine, we had seen just before. So why should we control and giving the controllable input to this load? Because we want to increase the efficiency and reduce the size of any application equipment. Okay, so to study and understand power electronics, power processing unit we had seen just before. Power processing unit, here it is. So power processing unit is made by power electronic devices based circuits. So you cannot use it directly power electronic devices. Of course, you are going to make some kind of circuits. So power electronic based circuits and control algorithms to control the flow of power to the load. I already told you the error signal. So we are taking the error signal as the reference based on the load requirement, and we are giving to this power processor. So everything together, it's working as a complete system. So first you should know about power electronic devices. What are the different power electronic devices and how can we use them? What is the VI characteristics of such power electronic devices? So it means you need to study and remember some PE devices symbols and working principles of some PE devices and their VI characteristics. V means voltage, I means current. Voltage and current characteristics of such devices. And of course, some relevant mathematical equations. So if you have questions, you can just come up with question anytime.